My name is Miguel Angel. I am from Argentina. I work in the University of San Martin. And when I started this project, I had a problem. That is, I had to debug a module in VHDL. And the problem is that the equipment are really expensive for this. And also, even if you have the equipment, then you have to connect all the sensors, and sometimes that is not very accessible. So what I was trying to do with this at the beginning was a simple way to show any signal, digital or analog. The analog is harder because you want this to be continuous. And also the problem is I didn't have a DRAM controller. And I want to use also the DRAM to store the data. Because I can see here that is, I don't have much to see here, but in the case, what we are trying to do was digitizing a signal that was running at 100 megahertz and capture 1 second of this. So we have to store this in the DRAM. There wasn't other possibility. I found this kit that was really, compared to what they were at the moment, has 2 ADC, 14 bits, 125 megahertz with a bandwidth of 500 megahertz. So it was a really good ADC with a Spartan 3 for $200. And perfect balance for high speed signals. So I bought it and started developing. In that moment was a demodulator for signals similar to Wi-Fi. In fact, I don't know if you have the broadcast system, digital broadcast system that use that type of modulation. So to understand what was happening, I had to synthesize a signal inside the FPGA and watch it. You cannot do that. That is the only way is to send that bits to a DAC and then use an oscilloscope to check that signal. It's really hard to do that. So I decided that if I could see that signal on the video, I can understand better what was happening. So that was why I started to do this. So to debug things that are inside the FPGA. It doesn't matter if it's digital or analog. And not here is a simple application. But if you are designing a modem or something like this, you want to see the signals inside. That is your calculations. That's the problem, because you need to see if what you are designing is okay, and that is hard. So here is a problem: how you can do this without using a memory, a bit memory. And it's not so difficult because it's not that it's difficult or not. But the video, if you have a RAM with a video, you will read the data sequentially, one after the other, one pixel, then the next one, then the next one. This is what happens when we draw this type of signal, this type of graphics with a video card. That is called a frame buffer. I don't know, I explained it myself. Mm-hmm. So if I could generate the data in the same sequence, I don't need the DRAM. I can write directly from the video. So the idea is that if suppose that this is easier. Suppose that you are here. So you have to draw this bit. And then you have to draw this. So when you are going to draw this bit, this is the sample and this is the other sample. When you are in the middle of both, if you are here, you are not going to draw it. So if you are in this line, and the sample this line is between this sample, you have to draw this bit. Do you follow me, more or less?
Mm-hmm.
So the only thing that you need is to draw this bit. Is if you had only two comparisons, nothing else, and when the line is here. So in fact, I don't need to write this on the memory because this line is from the video card, is from the output of the video. So this is the vertical, and the X position is telling me what of the samples should I choose. So this is what how is this drawing. So when I hear that it's drawing this, the both sample is always checking that they are in the middle. Of course, it's only one bit, so it fits. So this is the only trick that is here to draw this signal. So I storage the whole signal to here, and then when it comes here, I read all the sample data and draw in real time. This is why it's so fast. The refresh time is the same refresh as the monitor or the projector. So there is nothing else than this. This is simple. Nothing else than that. So you can store all the signal that you want view, and I hope it doesn't. And then it works like a storage scope. So the data is stored in a block RAM inside the FPGA. And for example, let me see. This is a controller. Sometimes you repeat too fast.
Yeah, I hope that all buttons on this one work.
No, it works. It's the person who programmed this.
Okay.
So then, pressing the button.
Oh, it's nice.
And the same here. But that is more easy to think because we know everything about programming. Many people say, how can you do this without the frame buffer or the RAM? The idea is that I storage only the samples and then I read all the time. Maybe somebody can say, well, but you are reading all the time the same RAM. Yes, but the RAM is smaller because only has a sample that I wrote. And finally, is somebody asking about consumption and something like this. A smaller memory consumes less than a bigger memory. And if I have to write the whole frame buffer here, is in the end are the same readings that I had to do in a frame buffer. So this is how it works. So this is an application that is, I can tell you what a ScopeIO is, but if you don't see, you say, okay, Miguel, good work. Yes. But when you see it working, that's different. in this case, are 8 channels. And the number of channels, because this is multiplexed input that is in the ScopeIO, the maximum sample speed is 1 megahertz. So if you want 1 megahertz to be a signal of 1 megahertz, you can only have 1 channel. But if you want more channel, you have to reduce the resolution. So it's like appears others. And then you can change all this. So you have, when I exit this, exit. Here you can change the trigger channel. This is the trigger channel, the trigger system. Exit. This is the level of the trigger. This is its up and down. And this is, if it's normal, one shot, free running, or hold. Yeah. So you can choose any of this. But again, this is an application. That is, it is, okay, I have the ULX3 and I want to use it as an oscilloscope, a standalone oscilloscope. I want to see something that is 1 megahertz bandwidth, and I can use it as it is. But if you want, for example, along this year, my goal is to add digital signals. And those digital signals can be, in this case of this kit, as fast as 400 megahertz in double data rate. So that would be 800 transactions per second that I can read. And if you think about this memory, I don't know why, but Micron has a memory that can run at 250 megahertz. That is the standard one. And if you think about this and you multiply by 16-bit, that gives you, for one signal, a maximum transfer rate of 1 gigabit. So this is what you can capture with this hardware, as it is, without changing anything. For example, you have a serial line input, you can capture the whole data and storage in, I think was 32 megabytes of memory. Enough to see what is happening. This is ScopeIO. That is that the clocks that are here are only the clocks to support the ADC that comes in the ULX3. But it's not limited to that. You can make it go as fast as you can. And others in the same FPGA, we run in the foreign version the 400 megahertz DDR3, and it works. So I think that it could be fast enough to capture those data. So then, I don't know, you have any question about this? If you follow me.
Sure. Perhaps could you tell us about the trigger system that is usually quite tricky with analog signals, how to get it stable? Did you have any issues with that, or is it a question too early to ask?
No, the trigger is very simple, and the idea is that you can code your own trigger. That is, the trigger here is there is a block inside that is named trigger. So the only thing that it does is take the signal and telling you when it has to capture the data. So this is also, for instance, is a kind of demo. All the block can be changed according to your needs. So it's not hard coded, and because when I was designing this, I didn't want to force a trigger that is edge positive, edge negative, holding one shot. Was the standard that everybody was maybe thinking of the analog system. But for example, when I was working with the modem, I wanted the correlation signal, so I couldn't send the signal, the raw signal. I had to do a multiplication, I had to add, and then I had to trigger when I wanted, finding the maximum. That is where this kind of modem needs to be triggered. In that moment, you have the frame that you had to analyze. So the idea is that you can custom the system as you want. It's not mixed. It's a well-defined thing that is a trigger. For example, Emard write his own system to calibrate the trigger. I don't remember well, and that can be done in VHDL because you can have a component and you can replace the component without touching the code.
Yes, a few years ago I wrote a module with my own version of the trigger when I was also thinking how to do it and making some binaries and binary logical operations, and when I realized I know I'm ready to write the code, I did it. Now I also forgot how does it work. It can stabilize most of the signals quite okay. It's an external module which we can Miguel can have his own module. I can write my own module, and sometimes you need to trigger with something else conditions. So it's not a standard way. If something is complicated going on, it's good.
You don't need to know anything about ScopeIO to replace the trigger. The only what you need is, this is the signal. I sample, I checking what are the signals I find my condition, and I tell the capture system is ready, and it will capture the samples.
And maybe in Wednesday we can see the modules on the code. I think in Wednesday we can
Okay. Yes.
Yeah,
This is only a presentation. How it works in these basic ways. Yes.
Yeah. And maybe you can tell recently you got pulse view to.
Yes. This was a request from him. He told me can you connect pulse view and. So I took pulse view and checked. The documentation is really bad of full view. There is no documentation, but there is a driver that is named demo, and it seems that those guys wrote this driver, so you can go inside there and take what you need to write your own driver. So I took this demo and I make it work. At least this, for example, in the last version that is still not ready, but you can try. You can download this, start triggering, start working, and you connect pulse view with the modified library. You get run, and it dumps the data that was triggered.
What's pulse view?
Okay.
Program on the computers for logic analyzers and oscilloscopes. So it's open source and
Does it work in real time or?
I think he managed to get it in real time.
It works in real time. let's say that. When he introduced me, I was looking for the software, and I said, okay, it's triggering from time to time. I had to rewrite the ScopeIO to be more general, because in this version the trigger is inside of the waveform. when I had to add the possibility that pulse view or other need to trigger from outside, I had to extract the trigger outside the waveform. So, for example, if you want to use pulse view without the waveform, you can. You disable the waveform, the system will trigger itself, and they capture to the DRAM. They don't say the data to you. They capture to the DRAM, and you dump the DRAM into the PC. So you don't have problem if you are dumping the data from a serial port or you are dumping the data from an Ethernet port. The speed, the captured data doesn't suffer. That is this what I can say. The link speed. It won't be slower because you have a slow speed link. Doesn't depend on that. Depends on how fast the memory can capture the data. So again, having a memory of 250 megahertz, that is what you can capture. And then when the data is captured, the system is not real time. That is, it's not self-refresh. I ask to anybody that looking for anybody for any information, sorry, and the system is not self-refresh. That is, pulse view is not self-refresh. You have to press a button that is run, and it dumps what is there. So, as this, as the system is triggering constantly, that is in the case of you have the waveform, every time you reach the end of the frame, will trigger, is ready to trigger again, unless you put a hold or unless you set them free. But if it's normal, we'll wait for a trigger for the edge. If you let them free, it's triggering every time that ends the frame. So it's constantly triggering. And you can dump the data from the DRAM, and you can see the signals.
Can you explain a bit how the data is dumped? Before you have been using Ethernet to dump the data externally, and now USB, or?
You can use the link that you want. Mm-hmm. If you want to use Ethernet, you can use Ethernet. If you want to use USB, you can use USB. If you want to use serial port, you can use a serial port. Also, the serial port, the asynchronous port, has a checksum at the end that is similar to HDLC. So there is no problem with losing some byte. It will dump the data that was transferred and will request a new data. So there is no problem for it. That works for USB, and that works also for using a word. The Ethernet doesn't need that because it has its own checksum. So it dumps the data automatically. You don't need another checksum that could be something like overdoing things. But you can decide what you want. You are not forced, or you can. I don't know. If there is another kind of link, suppose that you decide to do a link with the HDMI, something like this, you can do it. You are not forced to use any of those. It is not embedded in the core of the waveform of the ScopeIO. This is outside. I did that on purpose because it's gonna be something big with a lot of modules that maybe the user doesn't want.
And in your library repository, there are already working examples.
Yes.
For the USB, for the Ethernet,
and for the serial port.
Serial port.
And some of for example, in the case of the ULX3, there are the 3 cases. So you can select if you want the serial port, if you want the USB, or if you want the Ethernet. Any of them, it works.
With ScopeIO or with some other software, the dumping of data is the encapsulation is done for the pulse I/O when the data is dumped over serial.
That is the driver in the pulse view.
Okay.
Ask to the device, give me the data.
Okay.
So the device is always writing the memory, always writing the memory. So if the trigger is the same position, the data will be very similar, like an oscilloscope. If, for example, you put in hold, it writes once, and it won't trigger again. So you dump it the last data. What I suppose is that PulseView had self-refresh, a system that is always asking for new data, and it's not designed that way. It's only that you press the run, and at that moment it'll dump the data, and that's it. So if you want a new data, you have to press the run again. I asked ChatGPT, as I think everybody's using it, and he told me no, and there is no plan to do that. And he told me, why don't you write a timer, and the timer triggers, run again, and run again. So in this case, will be a self-refresh. It's possible to do that. It doesn't seem to be hard to do that, but it's not, for now. It's not my intention. I want to work in the digital part of this that is simpler. I think is for many of us also is more useful than the analog part.
Can you example a little bit also in your code? There is something that writes the numbers on the screen and the text.
All this?
Yeah, all this.
All this is.
Yeah, this is nice and good. It doesn't need any of the softcore microprocessors.
No. All this is done by sequential machine. I don't know if you have heard about the double. That is. I need something to write.
Yeah, I can bring the board.
It's an old algorithm that is done in hardware.
Na drugoj strani ploče.
Yeah.
Sad nam bo. Vidite ga magnice.
To ne znam. We need to be in
Okay. So suppose this is 6 in binary, okay, and also in BCD. Yes. So suppose that you had to add to convert this number. If I add this number, it should be. This is not a BCD number. This is a number that is greater than 9. So it's not. It doesn't help. How can I say this? Something to.
Ne radi marker.
Ne, brisalica.
So this is 6. If I multiply 6 by 2, that is what's going to do when I move this number here, I have an overflow. So what I have to do, in what I really want of this is to have the number 1, that is, because this is 12, 1, 0, 1, 1 0 0 1 0. This is 12 in
BCD, okay.
in BCD. And then I can add this number, that is 13. So the algorithm says this: if you have a number that is greater than 5, because if I have this number, that happened too. Yeah, because this by 2, this is 10. So I have an overflow. I have to do the same thing. That is, what I need to do is having 0 0 1 0. This is the number. This is no, sorry, 0. This is the number. This is 10 in BCD, and when I add us, I will get 11 in BCD. But if I have, for example, 1 0 0, is I have to add this. This is 4 plus 2, and this is, there is no overflow here. That is, this number is valid. This is 8. If I add a 1, this is 9. 9. This is valid. So the algorithm says this: if the number that I have to multiply is greater or equal than 5, I have to add the number 3. So adding the number 3 gives me 0, 0, 0, 1. Then I displace this, and then add this number. This is a double daddle. It's a very old algorithm. So you can do this, and it works well. You have to use it, and you will generate a long number of combinationals. That's the problem. But if you have a number of 8-bit, it will work well. The problem is that, as you can see here, I have numbers that are 16-bit. So what I am doing, instead of doing this completely combinational, what I am doing this is in sequential way. That is, first I got the last digit, then I got the next digit and store in a register. So the combinational is short. It's not big. And the others are the register where you are iterating several times till you get this number. And then you write. This unit is very inexpensive, even though the whole horizontal axis has its own conversion system, that share the same conversion, the same hardware for this. That is, both of them are converted by the same unit. In this case, it's not difficult because it's only a multiplexer. So you have the vertical and you have the horizontal, and depending on where you are, what axis needs the refresh, it selects which is the number that is going to convert, and then they go to the memory. This is a block RAM with the characters. So this is, so you can, how can I explain this? You can put the number that you want. You are not limited to 32. For example, when I tested the system, with 64 bits, and I checked that the conversion was well done. And maybe for these numbers, maybe it takes 10 cycles, 16 cycles to convert the number. Nothing else. The hardware is very, very low. You are not paying much for that hardware. And you don't, the first version, that is on the YouTube, I think those videos are from 10 years ago. I was using a ROM. The problem with writing a ROM is that you had to select very well the numbers. And in the end, you are using, okay, maybe those, there are not a lot of numbers there. But in the end, if you want to have negative ones, more positive than this, you are using pretty much a block RAM with a lot of data. That's the problem. So then I changed it. The version that is coming in the ULX is a double-double, and the memory can be LUTs, the LUTs memory, the distribute, what's called the distribute memory, of only the numbers that you see in the screen. And every time you move the axis up and down or to the left, to the right, the axis is rewritten. So all the numbers are written again. When I do this, no. The numbers there are rewritten.
Oh, that's impressive.
So you don't need a CPU. You only need the system says I need to rewrite the axis from there. All these numbers are calculated in binary, and then is changed into BCD by the double-double. The double is really old. This algorithm is really old. When I met the first time, I didn't know that these algorithms were so old and weren't touched in logical systems, because it makes you in some way think about those things and how it works and the applications.
I have a diversion question, which is diverting, but those kind of algorithms may be simple in retrospect, but when you have to, as you said, extend it to multiple digits, convert it to a sequential machine, there are millions of things that can go wrong. So when Davor and I started with FPGAs, we were stubbornly avoiding doing any simulations. And I hate writing test benches, and I hate simulation. But from time to time, there's no way. So my question is, this looks really like a huge and complex project, and with really pesky and tricky bits like this one. So for this particular thing, did you debug it and?
No, I simulate. It's impossible. No, it's not possible. I had to simulate. No, it's not possible. No. I try to avoid. Sometimes I really try to avoid simulation. No. You can't do anything.
We're not the only ones who hate simulation.
Right? No. It's impossible. No. It's impossible. No. Sometimes I try to avoid simulation, and maybe
it's not fun.
No, it's not fun. You do, and you have to do everything to check. But sometimes you have to think about when I code in this. I said I don't want to do the simulation. And then I started to pass the time, and I stuck in the same place, and I really resist me to do the simulation, but I had to do it.
Okay. Thank
No.
you. Thank you. It's
No,
the
no,
same.
Okay,
I also try to avoid it.
but it's it's not
sometimes-
possible. It's not possible.
So the next question: what do you do? What do you use for simulation? Is it GHDL or
I
sim or
use model sim. Now it's also it's in the diamond lattice, and also it's in Quartus Altera. So you can simulate in Altera if you want using the model sim, because it's downloaded, but it's not integrated. And also I think you can download it without downloading the Quartus system and run it. But in the case is using the lattice diamond, the 3.12 has model sim incorporated. And that's also a good thing, because you have the low-level libraries there too. So if you want to use a that I had to use it for the 4M to run the DDR3. I have a problem. I didn't understand what was going on. I simulate functional that without the delays, and I couldn't find what was going on. I had to be patient. Yes. Compile everything. Yes. Compile everything and run and find the problem. There are some basic blocks that are in lattice that are not well documented and are very dark for what it is DDR3. And they don't say anything. So it's many trial and error to understand what is happening and compare to the data that Goran was sending to me, because they tell me it's not working. I asked it the data to understand what was going on. And then we could find the mistake, and when he told me, hey, it's working, it really was an exciting moment for me, because sometimes you don't know where to go anymore. You say, I try everything, and you don't know. Yes, simulation is
the way out?
Yes. No, you can avoid it. Can avoid
to
it.
use LLM with simulation output and then to summarize it at least. So you can help like LLM, like large language model, to actually help you summarize it.
No, I use BHDL, the same BHDL. I write all the test benches in BHDL. I don't want to add a third tool. So I use BHDL, I write the test bench in BHDL, and simulate and compare the data. There is, as I say, how can I tell you? There is no free lunches.
Is it a difference between Diamond 311 and Diamond 312 that 11 doesn't have the model sim, or it has it?
311 doesn't have model sim, 312 and 313. I'm using 313 model sim from 313, and it does its job quite well. But my question is, does this thing synthesize properly with 312 or 313? Because we have noticed the last diamond that actually produces usable bit streams was 311. 3.9 is the best, absolutely, for me. But 312 and 313, well, for me it produces rubbish, even on simple counters. Or
This bit file is generated with a 312.
312.
Yes.
Okay.
Maybe yes.
With Simplify Pro or LSA or
No, Simplify Pro, the one that comes from Diamond, and with the standard license, no other license. Maybe it's the memory. I have problem with, okay, Vivado is a problem itself, but I have a similar problem that you have now, and it was related with the memory. So I had to add it swap, more swap, and it finished the job. And it finished saying segmentation fault.
More swap.
But maybe that can help.
I will try. Is it maybe it is for the next day of the lectures? But I saw some kind of a strange syntax in your code, very interesting. It uses double stars and the string, like something is raised to the power of the string.
Yes. Can we connect, I don't know, a computer to show that syntax?
Yeah,
Because
but maybe that's good for the next time.
Yeah.
Because
Okay.
then we will have a computer
Okay.
and code.
But
You can say like
I will tell you simple. The problem, I don't know you remember, in the legacy code you can see that there is a package with all the definition of all the displays on all the things. If you see that structure, you die, then you won't try to ScopeIO, because even the parameters are needed for a user the first time that met that say, no, this is not for me, I'm not going to use it.
It's not friendly.
Yes, it's not friendly. So the problem with the structure of VHDL also maybe is because it was done in a moment that the 80s and the 90s, and nobody was thinking about maybe objects, is that it's very rigid in that way. For example, if you want to add a variable vector, you can't. And if you see the whole entity of the ScopeIO, I have to define a lot of parameters to have different size. This is a problem. This is very. It's not friendly. It's not friendly. It's trying to push you away from that. So I remember the JSON in JavaScript. I don't know if you have seen that, and it has a very simple structure to describe this kind of object, and that is a string. So then I check other languages to see if that more of them are scripting languages, like Python. I don't like Python, but I check it anyway. Lua and others, and JavaScript was the only one that has one character token. So you don't need to find two characters to find a token. You have a comma, you have a colon, and that is a token. That's it. In the case of Python, you have some of them are two character token. Lua has the same problem, and Perl has the same problem. So what I did was parsing a JSON JavaScript object in a package. So the idea is that you can cut part of the string, and this is, I want that parameter. And then you can convert to integer, you can convert to a string if you want a string. And also, that helps. For example, if you don't define a parameter, for example, you don't want the SDRAM here. If you don't define the SDRAM, you can add a default. That is, if the parameter wasn't defined, you can add a default value. This is not in JSON, this is not in JavaScript, and it gives you that default parameter. So you can check it. If the SDRAM is not there because the user didn't define it, and doesn't need to define it because they don't have it. So the system check that and disable the whole core without you knowing if you had to define the SDRAM or not. And that's only in a string. So for VHDL, it is a string. And I was really surprised that the tools works. I hope that Diamond works because Synopsys is really, I think it's the best. It has their bugs, I don't deny it, but it's really the best. But what surprised me more was that the old ICE Xilinx compile it. They don't have a problem because that compiler is really old, and they parsed the system and took all the parameters, so you don't have to worry about this. So because also PHDL has a problem, but it's not that it has a problem that itself is if you have a port, no? This is the entity where you are defining. Here you have a port, and then you have a signal XX, and then you have you have a vector, a logic vector. If I don't define the range of this, it will give me an error. And if this suppose that it's the input of the DRAM, because this is wrong, and you don't want to use it, you have to define at least the range. That's the problem, because it's not friendly. Why should I need to put a port here for VHDL that is not going to use and will be disabled at the end? VHDL needs this because if you use this in a for or in a loop or something like this, it needs to know where to start and where to end. And if you don't connect, it doesn't know that. So with this system, I can check if the parameter is defined, and if not is defined, I can give them a range without the user knowing that. So I can have all the ports of the DRAM, and the user doesn't know it if he didn't want to. And if he defined the DRAM, they would define the port for that DRAM. So I have a database system with all the chips, and if none of the chips solve your problem, you can describe in the same JSON your own memory bus, the own memory system. So it's what I'm trying to do is trying to satisfy most of the user.
And the tools.
And the tools.
Yes.
And the tools, yes.
Tools first, users can wait.
Yes, tools first.
Yeah, I think they tortured you enough for today. So
Okay. Thank you, Goran. Thank you, Goran.
Because also in Wednesday they will have time to have more questions, and then 2 more days. So
Okay. Thank you.
Thank you a lot.